Today we find ourselves in 10.2. I am almost as excited about this one as I was 10.1. Maybe just as excited. We're going to start significance testing, or also called hypothesis testing today. And hashtag WHAPS, it's not WAPS, it's WHAPS, is an acronym that's just going to help us remember the steps of every significance test we do. And I just put a hashtag on it because that's what you kids do these days. Significance testing means this. There's a claim or a hypothesis or some number that's supposed to be the truth. An outcome, so I assume that's true, an outcome that would rarely happen if the claim were true is good evidence that the claim is not true. Okay, here's our example. We golfers are usually over-exaggerating our skills. So a golfer who says, my average is 78. Maybe they shot a 78 once, but we don't want people to know how bad we really are. So we say my average is 78 because we always think we're going to do our best on every single day. Okay, Mr. 78, I believe you. Now let's see how you play. If you truly are a 78 golfer, then your scores should act a certain way. Now we're talking about a sampling distribution. We'll talk about the assumptions and all the conditions and all that in a minute, but for now let's just talk about the sampling distribution. Okay, you're really a 78 on average. If I watch you play 30 times and take the average, that's one measurement of a sampling distribution. That distribution should be centered at 78. Now, the standard deviation we would calculate with our formula, sigma x bar equals sigma over square root of n. In this case, that n would be 30. I'm not going to put specific numbers on that, but let's just say with 30 scores, let's just say that's 1, so 79, and I don't know. It would depend on what the population distribution was, what the population standard deviation was, but let's just go with this. Let's just say it's 1 for argument's sake. So if you really are a 78 on average, and I look at you play 30 times, this is the distribution that it should follow. Okay, so if I see you play 30 times and your average is a 79, fair enough, no biggie. But if I watch you play 30 times and you score an average of 82, way out here, then that gives me some serious doubt that your claim is actually 78, because I know what the sampling distribution would look like if it really were 78 and you're recording 30 scores. Okay, 80 to 81, very rare. All right, if you really are a 78, then you're going to be shooting below 80 on average if you're looking at 30. All right, so again, that underlined is an important statement. An outcome that would rarely happen if a claim were true, such as 82, is good evidence that the claim is not true. There we go. I have evidence that your claim is not true. Now let's go through the acronym. The W in WHAPS is what test you are using. We're going to do a bunch of different tests. What we're doing right now is a z-test. Just like a z-interval, we're using a z-test because the population standard deviation is known. I guess I needed to write pop because sigma implies population standard deviation, but that's known. This test could also be known, to be more specific, as a one sample z-test. Because what I'm testing is I'm gonna record the mean for my sample, and I'm going to see how unlikely it would be, assuming that the claim is true or the hypothesis is true. This is a one sample z-test, another name for it. It tests for population mean. Okay? Whatever the claimed number is, the average life of a battery or the average golf score, or whatever, we're testing to see how realistic that claim is. Okay, so W, what test are we using? Z-test. In your calculator, it's just called Z-test. Specifically, it would be called a one sample Z-test. H, Hypotheses. Okay, these are important. The hypotheses, there are two hypotheses every time. The null hypothesis, which is called H with the little zero, H naught, H sub zero. The null hypothesis is like the claim. It's what we assume to be true. All right, you always start one of these tests by giving them the benefit of the doubt and saying, okay, I'll say it's true, and now I'm going to test and see how realistic it is. Okay, so for my example, that would be that the average mu equals 78. Okay, the alternative this is called HA, and this is what we actually think, or our suspicion. It can be one-sided, such as, let me use a, pardon me, my phone's ringing mid-video. Okay, back to this. The alternative hypothesis, HA. It can either be that mu is less than, mu sub zero would just be the claimed mean. The, the zeros here correspond, meaning that it's less than whatever the claim was. Okay, it could also be that it's actually greater than, or in kind of a case that I don't like too much, and I'll tell you a lot about why. It could be that it's just not equal to. Sometimes you don't know if it's, you don't suspect it higher or lower, you just don't think it's true. Like maybe you're in a factory making something and it needs to be 5 inches. Well, you just need to make sure that it's 5 inches, and you don't know necessarily whether it's going to be bigger or smaller. So sometimes it's just not equal to. For our example, I am claiming, because we golfers are such big shots, that the average is actually greater than 78. Okay, so these are our hypotheses. Every single time you do a test, WHAPS, the H is you're going to list the two hypotheses. The null hypothesis, the claim, the alternative, what we suspect might be true. Okay, moving on. Assumptions and conditions. There are two conditions for a z-test. Number one, simple random sample. Okay, there's a difference between assumptions and conditions. The condition is a simple random sample. Okay, it has to be that. The assumption might be, hey, these 30 golf scores are a simple random sample of all golf scores. And that's an assumption because it's not really true. You can't really take a simple random sample of all of somebody's golf scores, all right, because they're not independent of one another. There's a lot of issues, but we can make that assumption to support this condition, basically. So either it's an SRS or we just assume that it's enough like an SRS to be okay. Secondly, this is the same as it was for intervals. Either the population is normal or n is greater than 30 to make the sampling distribution normal. All of this math is based on a normal curve. So our sampling distribution must be normal, and if the population is not normal, a sample size of 30 or more is going to make our sampling distribution normal. So two conditions, and we got to start learning the difference between an assumption and a condition. The condition is the random sample. The assumption might be, like I said, these 30 golf scores are going to be considered a simple random sample. Maybe or maybe not the truth. That's why it's an assumption. Okay. P, perform the test. Okay. Here's the magic that we're looking for, the p-value. We are looking for a probability. This probability is the likelihood that our result would happen if the null hypothesis were true. So I'm assuming you're telling the truth, And then I'm going to get the probability that you actually did what you did, assuming it were true. Now, this is like most of the things we do. We're going to have a formula, and then we're going to learn how to do it in the calculator. But as long as we're here doing some, as long as we're in the simple ones, we're going to do them both ways. Okay, here's the z. And this is a z, like z last semester, all right? It's a standard, it's a value on the standard normal curve. It's a z-score. The formula for z is x bar, the sample mean that we actually got, minus mu sub 0. This is the claim. This is the mean that the null hypothesis stated, over the standard deviation, sort of. This is our adjusted standard deviation, which is called the standard error. So you use this formula, you get your z-score, and then you draw a normal curve and see what's the probability of something as rare as this z-score. Or calculator. Okay, so we'll get to the formula with our example in just a minute, or you could do it in the calculator. But what you need to know for sure is what a p-value is. Make sure you write this down. The probability of getting the result we got, or something further away from the middle, or something more messed up, or worse. I mean, I guess worse is bad because it implies it's always negative, but it could be or different or better. But it's something we got, let's just call it this, or more extreme, if the null hypothesis is true. All right, it's the likelihood that we get what we get, assuming the claim is true. You need to know that definition. All right, so that's actually doing the test, getting the p-value. And when you're done, you say, what does that p-value tell me? Okay, well, what you're going to do each time, based on your p-value, is you're either going to reject or fail to reject the null hypothesis. Notice, neither one of these say except. You might think the opposite of reject is accept, but we'll talk in more detail why that's not the case. We never really say, okay, I think you're telling the truth. We just say, all right, I don't have enough evidence to call you a liar, basically. So you're going to circle one of those, or you're going to write out one of those. We either reject or fail to reject at the alpha. Okay. Alpha represents our significance level. And just like confidence intervals are usually 95%, alpha is usually 5%. Okay? Basically what that means is if the result that I get is less than 5% chance of happening, then I'm going to call you a liar. All right? It's kind of a gray area. It's not like if I get 6%, that's a really strong endorsement for their claim, but we have to have a cutoff point, so we usually call that 5%. And you can change it for a different test if you'd like to, but that's usually the one we use. So if it's so rare that it would only happen 5% of the time, then that's pretty good evidence that you're a liar. Okay? So we might say something like this. We conclude that, here goes our context, the actual average golf score, the actual life of the battery is greater than the number, whatever we're testing, 78. So this is kind of our template again. All right, you're going to say something like, we reject the null hypothesis at the alpha equals 5% level and conclude that the actual, or that the mean golf score for Johnny the golfer is greater than 78. Write this down. Realize you're not going to write reject / fail to reject. I'm just showing you you're going to choose one of those to fill into your template. So we're to an example. Johnny the golfer claims his average is 78. We actually watch him 32 times, and these are the scores he shoots. Now, just looking at those scores, you might think, okay, yeah, somebody whose average is 78 would have low 80s, high 70s. And we're going to test and see, is there average, or is there evidence that Johnny's average is actually greater than 78. Not quite as good as he thinks. All right, so I'm going to get my calculator ready here. Pause for a moment. Okay, hashtag whaps. Here we go. W. What test am I using? This is a one sample Z test because sigma is known, and also because it's the only one you know how to do right now. Okay, so on your paper you're going to write one sample Z test. On your AP test you don't need to write the W because that's just my thing for whaps or the hashtag. H, hypotheses. I've already kind of talked about these, but we'll write them again. Null hypothesis. Johnny the golfer, I assume you're telling the truth. Mu equals 78. Alternative hypothesis, what I really think, greater than 78. Remember, in golf, greater is not good. All right? And you might be asked to write these in context. And if you did, you would say right here, Johnny's average is 78, and Johnny's average is greater than 78. You don't always have to do those in context. It's a good idea. I'll tell you specifically whether you need to or not. So there's my hypotheses. Whaps. A. Assumption and condition. The conditions are SRS. My assumption, assume these 32 are in SRS. And you could write this in more detail than I'm writing. You could just say, assume the 32 scores are a simple random sample. I know that that's not really possible to take because you're just watching somebody play. You're not actually sampling anything, but that's the condition. You have to say the conditions. 2, n equals 32, which is greater than 30. So there we go. Assumptions and conditions. 2 conditions, the assumption in parentheses. P, perform the test. Now, you could also think of P as find the p-value. For the sake of time on this video, I've entered the values into my calculator. I took the 32 scores, stat, enter, and I put them in my list 1. All right, there they are. So if I go back to stat, over to tests, and choose option 1, z-test. Now, I don't know the average because I didn't take the time to figure it out. I could have, but I'm going to input data. I'm just going to actually give them the list. Okay? The first thing it asks me for is mu sub 0, which is basically the null hypothesis mean, 78. Assume the standard deviation is 3. Okay, so that should be just a 3. And list 1. Now, I'm going to select down here, list 1. Frequency, just leave that as 1. I'm honestly not sure what that changes, but my data is in list 1. My alternative hypothesis is that the number is greater than what Johnny says, so that's why I'm going to choose the last option there. And then you can either calculate or draw. Either one will work. I'm going to do just calculate now. So here's what it tells me. It gives me the z-score, which is actually over 5, which is ridiculously big. It gives me the p-value, all right, 1.478 times 10 to the negative 7th. Which, in this case, is practically 0. We found that in our calculator. So what is that? You need to know that a small p-value is strong evidence against the mean. Okay? If he's telling the truth, then a result as messed up as we got, which, by the way, it gave us the average to be 80.7. If he's really a 78 shooter, then an average of 32 scores being 80.7 is almost unheard of. So my little normal diagram at the very beginning was a little off. All right. Oh, S. State the conclusion in context. I'm going to try to get through this quickly. We reject. He's a liar. Maybe he's just an exaggerator. We reject the null hypothesis. Remember this. got a template. We reject the null hypothesis at the alpha equals any level, really. This is almost 0, so we would reject it at 1%. We definitely reject it at 5%. And the question was for 5%. So we reject the null hypothesis at the 5% alpha equals 5% level. Here. And conclude that Johnny's average is greater than 78. All right, so I'm trying to wrap this up quickly, but there's one time all the way through the whaps. Let's say that 600 times. So on AP test day, you don't forget all these steps. All right. We will spend a lot more time on this in class. Come with questions if you've got them. And that's going to be the end of 10.2. Out.